I'm going to show you how to use the wiki, and I'm going to post the question that in fact I had done on Friday. So you want to go to your class's wiki page. It's listed right here. I'll show you later what this looks like, but go to your class's wiki page. So for set 6, I am interested in the rate of change worksheet, so I'm going to click on this, click on rate of change worksheet answers, and then for this screen, what you need to do is edit wiki content. And the question that I'm doing is 6A, so in fact I'm going to put it right under Rio's. So this is problem 6A, and this is Ms. Sweetie. And this is kind of easy to do. So what I'm going to do is, the problem I'm doing is I'm looking for the instantaneous rate of change of x squared plus 3. So in order to insert my math type, I'm going to go right up here to where it has f of x, and I'm going to press this. And, okay, once it loads. Okay, so here are the tools that I'm going to be using. So I am looking for a limit, and I'm going to click up my limit and this button. So again, for a derivative or instantaneous rate of change, we're always looking for a limit. And I'm using the definition, the limit as h approaches 0. So there's my h approaches 0, and then I'm going to get out of that. And I'm going to have a fraction with a instantaneous rate of change. We always have a fraction. So you know it's going to be f of x plus h minus f of x all over h equals. And now I'm going to start tailoring this. So to make life easier, I'm going to copy the whole thing, just Apple C and or Command V, and my function here is going to be f of x plus h. I know is going to be, well, again, the function was x squared. Let me just go check. The function was x squared plus 3. So, okay, let me find the window I'm in. Okay, so our function was x squared plus 3, so this is going to be x plus h squared, and to square something I just use that. X squared plus 3 minus, and the function in fact again was just x squared plus 3. Okay, and now I'm going to copy this again and just reproduce this. So underneath, so I'm going to return, and I want to put spaces because you want to line up your equal signs. So this is going to be equals, and cut that down again. But I'm going to rewrite this. So I know when I square x plus h squared, that gives me x squared plus 2xh plus h squared. Okay, and plus 3 minus, and I'm just going to distribute the negative and clean that up a little bit. So again, I'm going to copy the whole thing here and return and type it. So notice that every single line is just a continuation of what had come before. I'm noticing my x squareds are canceling out, my 3's cancel out. So I'll just get rid of those. So all I'm left with is this. I'm going to factor an h out of the top. So I'm just going to rewrite this top. So this is just going to become h times 2x plus h. And now what I know will happen is that the h's are going to cancel out. And that's just going to leave me with 2x plus h, limit of 2x plus h. And now, in fact, now I'm going to take the limit, and I'm going to actually say, as long as h is close enough to 0, we might as well plug it in. So that's just going to give us, so line up the equal signs, equals 2x. So what I have shown is that the instantaneous rate of change of this function at any point is going to be 2x. That's my answer. I'm going to press accept, and this should go right into the slot. So there's the answer to 6A.